Hi, my name's Skylar Hogan, and this is the um, experiment presentation. So, the goal and design of my experiment it was to determine the change that occurs when the discharge is altered. And the design will be I used a PVC pipe to act as the stream, and um, there was a 2-liter pop bottle at the top end to regulate the water that was going in. And the entrance hole for the float was a few inches down the pipe, so then the float wouldn't start where the water was more unpredictable up at the top. It had calmed down a little bit down the pipe. And then, so method, got a few different things here. So there's a stopwatch, and when I put the item down the tube, I used a little piece of tape that I rolled up, bright orange tape, so it'd be easier to see. And the stopwatch was started when we released the tape through the hole and stopped when the float came out the end. You can see on the circle little diagram there, that's how I measured the depth. So when the water was running, I put 2 little lines on the tube on each side of the water stream. So like the 2 pink lines on the bottom could be where there was less discharge, and the more purple looking lines would be where I turned the hose up and there was more water coming out. And then the diagram on the right here, the yellow rectangle represents the tube, the circle's the 2-liter, the green triangle's where we had the hole located for the tape to get put in, and then the dark pinkish purple triangle was the object that propped up the whole experiment. Then, so to calculate the measurements, I used the what are they called? Equations that are in the little chart there. It was just the ones we were given for the lab. Alright, and then the results here. So the average velocity for a third of a turn for the faucet was 72.19 centimeters a second, and the depth was 0.76 centimeters. The average velocity for a whole turn was 83.63 centimeters a second, and the depth was 1.5 centimeters. And I figured it out by plugging numbers. Oh, yeah. I was just reading off my lab report here. And then these tables are the ones that I used right in my my lab report and in my notebook, because it's just I made these before I started the experiment and then just plugged them in. So I determined that an increase in discharge equaled an increase in the velocity that the tape went down, and it also increased the depth. This would probably be the same as a stream, given that the stream stayed about the same size, because like if maybe it was a really big stream, like wide, then maybe the velocity and depth wouldn't have changed as much. Alright, so interpretation, yeah, it showed what I expected. I kind of figured if I had a set like channel for the water, if you turned up the speed on it, there would be more water trying to flow in, which equals faster run out time because the old water is pushing the new water, and then if the water can't get out fast enough, then obviously the depth will also increase. And then for future work, ways to improve the experiment would be to run the trial on many different size tubes to see how much the discharge really changes it for different sizes. So like to see if for a bigger size maybe um it wouldn't have affected the velocity and depth as much as it did, but I used 1.5 tube. So maybe for like a 2 or 3 inch, then maybe it wouldn't have done as much. And then another way to improve it was to use something else other than the 2 liter on the end, because while the 2 liter was good, the opening that went into the pipe wasn't very big, so I couldn't increase the amount of water as much as I maybe could have if I would have used something a lot bigger.